Okay, so we're going to give this a shot. This is the explanation of the bare basics that you need to know for the packet on the unit circle and radians. So some very basic things you know. Radians are a unit of measurement for angles, just like degrees. So there are 2 pi radians in every circle, just like there's 360 degrees in a circle. Radians and degrees both measure the size of an angle, just like miles and kilometers both measure distance. So they're just different units of measurements. So to convert between degrees and radians, you can always use the following proportion, which is right here. The number of degrees over 360 equals the number of radians over 2 pi. So I'm going to work an example down here at the bottom of the page. How many degrees is 1 radian? So put 360 down here, put 2 pi over here. I know radians. I'm trying to figure out what 1 radian is, and I'm solving for degrees. And then you just cross multiply and solve. So 2 pi d equals 360. Divide both sides by 2 pi. And you get that 1 radian is 360 over 2 pi degrees. 360 divided by 2 is 180 over pi. Pi is about 3. So 180 divided by pi, if you put it in your calculator, you're going to get a number close to 60. So 1 radian is about 60 degrees. All right, sometimes you're going to want to convert the other way. So how many radians is 210 degrees? So same proportion. This time I know the degrees, 210. I'm trying to convert to radians. And what's going on with my pen here? Oh, that's super frustrating. Okay, sorry about that. The pen stopped working, so now I'm going to draw with my finger. Anyway, so you have this proportion. 210 degrees over 360 equals r for radians over 2 pi. We can simplify the left-hand side. 21 over 36 equals r over 2 pi. You can then cross multiply. You get 42 pi equals 36r. And then to solve for r, you just divide both sides by 36. And when you reduce 42 over 36, both of those are divisible by 6, so you get 7 pi over 6 radians is equal to 210 degrees. And that's how you do that problem. Okay, so now that you know what a radian is, you can look at the unit circle. So the unit circle was covered last year in geometry. It's the same unit circle, so the definition of a unit circle is a circle that has a radius of 1. Here's a diagram of the unit circle. We'll be using it again this year, but all of our angle measurements are going to be in radians instead of degrees. So on this diagram, you can see right here, 30 degrees is pi over 6 radians, 60 degrees is pi over 3 radians, 90 is pi over 2. Halfway around the circle is pi radians, because there's 2 pi radians in a full circle, so halfway around is just 1 pi. Right now, you should pause this and download an image of the unit circle from the internet. If you Google unit circle with tangent, That'll be good. You should probably print it out or draw it on a sheet of paper because you're going to be using it for pretty much all the problems in the rest of this unit, so it's good to have a paper copy of it next to you as we move on. Okay, so the reason the unit circle is useful is that as you go around the unit circle, the coordinates, so here, like the coordinates, actually give you the sine and cosine of the angle. So, for example, if I wanted to know what is sine of 4 pi over 3, I'm going to go around the unit circle and find 4 pi over 3. It's right here. And since I'm looking for sine, I want the y coordinate. So the y coordinate right here is negative root 3 over 2. So if I wanted to figure out what is the sine of 4 pi over 3, I go there, look at the y coordinate, it's negative root 3 over 2. So there are 2 example problems at the bottom of this page. Why don't you go ahead and try those, pause this, try them on your own, and then when you think you have the answers, unpause it, and I'll write in the answers in just a second. Okay. The first one, cosine of 3 pi over 4. So I'm going to go to 3 pi over 4 on the unit circle. Oh, the over 4s aren't on this unit circle. If they were on here, it would be here. And the coordinates at that point are negative root 2 over 2 and positive root 2 over 2. So cosine of 3 pi over 4 is actually negative square root of 2 over 2. I have no idea why the over 4 angles are not on this unit circle. Yours, the one that you print out from the interwebs, should definitely have the over 4s on it. Okay, the next one, sine of 11 pi over 6. So I'm going to start here, go all the way around the circle, I look for 11 pi over 6. It's right here. Since I'm looking for sine, I'm going to look at the y coordinate. The y coordinate at that angle is negative 1/2. Okay. So there'll be some problems on the test about this. You'll have your unit circle on the sheet you can bring in. Okay, a negative angle measurement means that instead of rotating counterclockwise like this, you just rotate clockwise. For the example down here at the bottom, at the top of the page you see, so the angle negative pi over 3. So I start here, and I go pi over 3 radians clockwise. I end up right here. That's going to be the same angle as if I had started here and gone positive 5 pi over 3. I end up at the same spot on the unit circle. Okay, the last part, if an angle is greater than 2 pi, you just make a full rotation around the circle and then keep going. So I'm going to erase what we had here. Okay. So, for example, sine of 10 pi over 3. So 10 pi over 3 is greater than 2 pi. 10 divided by 3 is more than 3, so it's bigger than 2 pi. So I need to figure out, so that's going to be 1 lap and then some extra. So I need to figure out how much that extra is. So I'm going to do 10 pi over 3. I need to subtract 2 pi. So I'm going to take away a full lap. You need to put 2 pi over a common denominator so that you can subtract them. So if we put 2 pi over 3, that's going to be 6 pi over 3. So 10 pi over 3 gives you 4 pi over 3. So what this means is that the angle of 10 pi over 3 means go a full lap all the way around, and then you're going to go 4 pi over 3 more units. So as we're starting our second lap, we're going to land at 4 pi over 3, so we're going all the way around, and we end up right here. So 10 pi over 3 lands you at the same place as just 4 pi over 3. Since we're looking for sine, I'm going to look at the y coordinate. There's a bunch of drawing on it now, but it's negative root 3 over 2. So the answer to this one is negative square root of 3 over 2. Okay, you're also going to have to find tangent every once in a while. So tangent is equal to sine over cosine. And since the y-coordinate on the unit circle tells you the sine, and the x-coordinate tells you cosine, it's also equal to just the y-coordinate of an angle divided by its x-coordinate. So if we're looking at, for example, at tangent of 7 pi over 6. If you go up to your unit circle, let me erase the stuff from before. Okay, so 7 pi over 6 is right here, right? So the y-coordinate is negative 1/2. The x-coordinate is negative root 3 over 2. So negative 1/2 divided by negative root 3 over 2. Sorry, it's hard to draw small with my finger. Gives you negative 1/2 times negative 2 over root 3. Okay, the 2's cancel. So you get negative times negative is a positive. So you get 1 over the square root of 3. So some unit circles that you print out from the internet might have tangent written as 1 over root 3. 1 over root 3 is the same thing, is the same number as square root of 3 over 3, so sometimes you'll see it written like that as well. So to find tangent, you find the angle on the unit circle, and you divide the y-coordinate by the x-coordinate. Alternately, a lot of unit circles that you find on the internet have the tangent values written in around the circle. Okay. So the very last topic here that you'll need for the test is arc length. So here's an example problem. A tire has a radius of 1.5 feet and completes 5 revolutions per minute. If it travels for 6 minutes, how far did it go? You actually don't need any trig to do this problem. It's kind of common sense. You do need to know that the circumference of a circle is equal to 2 pi r. So the circumference of this tire is 2 pi times 1.5, because that was the radius, which gives 2 times 1.5 is 3, so the circumference is 3 pi. So every time it makes a revolution, it completes, it goes 3 pi feet. Okay, so we're told in the problem that it completes 5 revolutions per minute. If it travels for 6 minutes, it's made 30 revolutions. So 5 minutes times, 6 minutes times 5 revolutions per minute equals 30 revolutions. And we know it goes 3 pi feet per revolution. So you multiply the number of revolutions by the circumference, 3 pi. And so in all, it travels 90 pi feet. And that's it.